Hello and welcome to Castle's Corner. I am Coach Castle, and today I'm going to be digging into resistance bands, the good, the bad, and the ugly. How effective they actually are at building muscle and practical applications. Hello and welcome to Castle's Corner. I am Coach Castle, and I'm here to educate you in the latest science regarding biomechanics, biochemistry, respiratory health, nutrition, and much more. Please remember to subscribe to this channel and like these videos if you find this content helpful. But now, for starters, what are resistance bands, and how effective are they at actually building muscle? The first thing we're going to have to do is look at the bands themselves and then get into the actual science of determining if they're effective or not. So, although training with bands has become very popular, there appears to be a lack of fundamental knowledge in the usefulness and application of this method of training. For example, the basics of how they affect force production and whether or not they can improve maximal strength in untrained and trained individuals. Now, in many cases, band training is used to improve an athlete's ability to overcome the sticking point of a lift or to increase the force production in the latter stages of the exercises or the end range of movement. Now, resistance bands are customarily measured for weight resistance level by the manufacturer using their preferred type of scale. The band is simply anchored to the scale, stretched, and a reading is taken at the beginning of the pull, then again at the furthest safe distance from the anchor point. An average is then calculated from both readings and is used to decide the equivalent pounds of resistance. For convenience, most resistance band manufacturers will abide by a common system of colors to help people conveniently identify the different tension levels from easiest to most heavy duty. Now, resistance bands fall into two main types: flat sheets with no handles, and rubber tubing that may or may not have handles of some sort attached to them. Each of the two types of resistance bands has different design options that make one or another better for some form of training. Flat sheet resistance bands can be long sheets of rubber that are gripped by the fingers or wrapped around the hand when used. These types of bands are used in physical therapy to rehabilitate certain injuries typically. Now, flat resistance bands that are made into loops, such as the ones here, also have no handles and are used for a large variety of exercises, provided you understand how to apply them essentially. Now, tube resistance bands are used more appropriately for conventional bodybuilding and strength training. There is a wide range of different configurations available with the sturdier tube band. And resistance bands with handles attached, of course, is the second kind. This is the traditional tube resistance band, has handles permanently attached to them. To vary the level of exertion, you're going to need to buy multiple resistance bands, as these don't really fold well, as the doubling effect is a little bit complicated to explain. Now, tube resistance bands also come in different configurations that are specific for certain types of training. And now, of course, there is also bow tie resistance bands. It's just a bow tie design, and then there are tube resistance bands that are no more than a foot or so long and have Velcro and ankle cuffs. These are specifically for working the lower body, the hip, things like that, etc. But again, how effective are these things actually for hypertrophy? Now, let's get into it. As you all know, the process of muscle growth is known as hypertrophy, kind of a catchword. Now, there are three main mechanisms for hypertrophy: mechanical tension, muscle damage, and metabolic stress. Mechanical tension is the process of loading the muscle in some way and creating tension. Now, resistance bands do, of course, offer some form of mechanical tension. Out of the three mechanisms for muscle growth, mechanical tension is by far the most well-established and clearly the biggest contributor. With bands, the resistance is not caused by the force of gravity as we see with free weights, but they do offer a mechanism for loading our muscles through elastic properties of the band. When you lift a dumbbell, kettlebell, brick, whatever, the movement is resisted by the weight of the object. This is the weight of the object is the mass times the acceleration of gravity. In contrast, the same motion performed with a resistance band is resisted by the tension of the band. So what is that tension? The tension is a function of the amount of length that the band is stretched, as is described by something known as Hooke's law. In math terms, all it means is that the tension, or T, equals negative kx. Here, x is the distance that the band is stretched past its relaxation length, or the length of the band with no tension on it. Here, k is the spring constant of the band. K is determined by the properties of the band materials. Typically, resistance bands are made from latex rubber. So, I figured I better put some of my bands to the test, as I hadn't done this before. So, I hung each band over my scale with weights attached to the ends. I then placed different weights in the ends of the bands, measuring how much the band stretched each time. I then plotted the distance, x versus the weight, so I increased the weight until almost the max rating of the band, and plotted the change in the length versus weight. And, well, it's not a straight line. So, long story short, resistance bands do not follow Hooke's law, except for a very small range of weights and tensions and motion, essentially. Instead, the tension follows a curve. So if you really want to know how your bands function, you're going to have to measure them. So, for example, what I found was that a weight of 15 pounds stretched the band roughly 20% past its rest length. So anytime I want to achieve that level of resistance, I need to pull that particular distance. For a typical move, as you can see here with this biceps curl, the force I'm exerting is well below the max rated value. For example, this band is rated to 70 pounds. However, the distance at which I am pulling only corresponds to possibly a quarter of that. This in itself is annoying, but doesn't seem to be a big problem, right? Well, I'm not done yet. The second mechanism to produce hypertrophy is muscle damage. Now, muscle damage refers to the small muscle fiber tears that sometimes occur when lifting weights. These are more associated with the eccentric part of lifting, which is where your muscle is lengthening under tension. However, unlike free weights, resistance bands offer a very different resistance curve, which is quite the opposite to that which is provided by gravity. Take the bicep, for example. If you were to stand on one end of a band and curl your arm upward, reaching the full contraction in your muscle, as you can see here, the band is offering the greatest resistance at the conclusion of the movement when your muscle is fully contracted or flexed. At the beginning portion of the movement, there will be zero load on the bicep, as you can see, gradually increasing throughout the resistance curve until finally peaking at its conclusion of the movement where the muscle is fully contracted. Now, compare this to free weights and the use of gravity. The resistance curve is such that there is no load on the biceps when it is at rest. However, at the beginning portion of the movement, the muscle will be contracted with maximal force due to the muscle being at a mechanical disadvantage. However, as it passes through the arc of motion, nearing full contraction, the form at one point in time will be parallel with the floor and perpendicular to gravity. At this point, the dumbbell is the furthest from the pivot point as possible, meaning it is as long a lever as it can be at this movement, or a 100% active lever. Past this point, the resistance curve again diminishes towards the fully contracted position, ending with less load on the bicep in the fully contracted position, where it now has mechanical advantage. Now, this does, in fact, go with the laws of nature and how muscles operate with a correct resistance curve. Muscles must always begin from an elongated position, as well as a mechanically disadvantaged position for maximum efficacy. Then, as it passes through a resistance curve of various resistance and concludes with a mechanical advantage in a fully contracted muscle. This is the proper resistance curve and will always yield the most effective results for muscle growth, period. The problem, as seen here, is that resistance bands do not offer this correct resistance curve. Although they do offer a different form of varied load muscle damage, it is highly correlated to the lowering portion of the rep, as well as being in a complete opposite resistance curve than what muscles have evolved to do. So, that's a big problem. Now, to be fair, Having peak tension just before this lowering may provide some benefit to muscle damage. But again, bands essentially provide the most resistance when your muscles are weakest, shortest, and with the most mechanical advantage. And zero resistance in the most important part of the movement where a muscle fiber is selective and your muscles can generate the most force. And then finally, the third stimulus for hypertrophy is, of course, metabolic stress. Now, metabolic stress refers to when your muscles get low on energy, which leads to the accumulation of something called metabolites. Now, metabolic stress is most often seen when you chase the pump and perform tons of reps over and over until the muscle is pumped up and exhausted. It is a physiological process that occurs during exercise in response to low energy that leads to metabolic accumulation such as lactate, phosphate, inorganic, and ions of hydrogen in muscle cells. Now, traditional resistance training has an important impact on the increase of metabolic accumulation, which influences hormonal release, hypoxia, and cell swelling. Changes in exercise routines such as intensity, volume, and rest between sets are determinants for the magnitude of metabolic stress. Furthermore, different types of training, such as low-intensity resistance training, or blood flow restriction training, or high-intensity interval training, could be used to maximize metabolic stress during exercise. During the last decade, blood flow restriction training, also known as occlusion training, combined with low-intensity strength training, roughly 20 to 30% of your 1-rep max, has been shown to increase strength and muscle size among trained and untrained athletes, as well as the injured and the elderly. Now, this training model requires the use of cuffs that are placed on the proximal ends of the upper arms and thighs, reducing blood flow from the muscle. Thus, the external pressure applied maintains arterial inflow while blocking venous outflow of the blood, resulting in an ischemic hypoxic environment that enhances the training effect. Now, it is not clear if the maximal degree of muscle hypertrophy can be optimized by increasing external loads, or if the ceiling for maximal hypertrophy is achieved with low-moderate loads. Now, this is a lot to take in, and the reason I'm bringing all this up is because the resistance that resistance bands provide is quite complicated. Resistance bands will also be loading your muscle exactly opposite its natural strength curve, and is already previously addressed, although they do add benefit in the second half of most movements, and are certainly very versatile and useful in certain sport-specific activities, and occasionally reduction in body weight activities and exercises, such as modified push-ups, chin-ups, step-ups, or, a large range of other body weight exercises. Just get creative. Long story short, unfortunately, there is no conclusive data on the effect resistance bands have on muscle growth, although it does certainly seem to me, looking at all of the science, that it is very minimal. And another particular issue that I have is if everyone is going to be using resistance bands and they're always talking about how cheap and portable they are, it frankly doesn't make sense to me why you would not simply make yourself a portable keychain gym and use your knowledge of biomechanics to your advantage. Simply using your body weight and a bench, you could get a perfect workout provided you knew what you were doing. You don't even need the keychain gym. By the way, a keychain gym is just something you could make for yourself. It's 2 micro pulleys, a cable or a nylon cable, a handle, and then some form of a collapsible bucket or bag on the end. Trust me, it works great. You just gotta have the right information. No more gym is needed. I'll link a video on how to make one at the end of this video. And by the way, yeah, it's really cheap and super easy to make. Don't worry. And as you hopefully already know, anything can be weight, from your body weight to water, dirt, rocks, kids, pets, spouses, books. You guys get the idea. Now, if you have the correct knowledge and information to apply to your own body, you'll never have any issue performing these perfect biomechanical exercises for maximum muscle hypertrophy anywhere, anytime. Now, on a side note, I am very soon going to be conducting a study to test the effectiveness of adding resistance bands to free weights and or cables at the same time. Now, this is going to be done with the correct biomechanical exercises to see if the previously mentioned qualities in the second half of the movement with the resistance band will add anything extra to the process of muscle hypertrophy. Anything from perceived muscle fatigue to increased metabolic stress, increasing neurological connection or mind-muscle connection with the muscle, or perhaps even stabilizing and reducing momentum in certain individuals, which would also lead to an increase in hypertrophy. Now, if anyone is curious who watches this video, please just let me know by email or in the comments or something, and I'll send you all the relevant details to the study, which will be taking place within a few months' time when I have enough of the appropriate participants. I would also like to give a shout out to the video's basically donor and sponsor for today, lecardio. The company sponsored this video. They also sent me quite a few resistance bands to test out and break in at my leisure. I agreed, provided I would be giving constructive feedback. Now, I did warn them from the very beginning that I would be holding back no punches, and I would strictly be digging into the science behind resistance band, and a lot of my conclusions might not even be good for their company. But they didn't mind in the slightest, so I'd like to really, shout out respect for that. Now, on a brief note, I would like to say that their bands are pretty amazing, very consistent in their strength and durability, and I actually kind of like the versatility of them. They really made me stretch my creativity. I tested them quite extensively over the past 2 months, and only one of the weakest ones broke, and that's on me, because I wanted to see the actual limits of their capacities, as well as what happened in the event one was to fail, how you would get hurt, essentially. I have included quite a few different banded videos, as you can see, and I hope you find them helpful, and all of them will be individually added to my exercise library playlist, so you can find them at your leisure. Just little 1-minute clips of me performing one particular exercise, guys. Real easy. That way you never have any questions. I would like to also remind you all to check out my Etsy store, where I have all of my books, as well as many tools available for download. For the price of a coffee and an omelet, you can have all of the information you could ever need downloaded instantly and good forever and able to share with anyone at any time. And of course, you'll be helping me to make more of these videos. And if you want to take a direct hand in supporting this channel, please consider joining, as you'll receive lots of additional benefits, questions with me, free coaching calls, you'll get my books in audio format, tons of videos other people don't have access to, all kinds of stuff. Now, I hope you found this video helpful, and thank you all very much for watching and subscribing. Every little bit counts. Don't forget, get your finger exercise in and help me out at the same time. Like, share, comment, and subscribe.